Okay, so last session, woohoo! So, I know you're all tired, you want to go home and stuff, but thank you for coming. It's going to be super short. And let's kick it off. So basically, the basic premise is kind of known from the title, and that is the exploration of what friends are for. So this book actually came out in '38. It was an interesting finding. It's a like highly influential book about influencing people and having a lot of friends. The basic premise is that friends are your enemies. So what does this mean? How many times did you experience a situation that you were either asked to help someone, a colleague, a friend in the company with doing some work? Like, if you could like just do the thing you did last time, or remember that thing, that client, and we need to do the thing. Remember the thing that when it crashed and you helped me with blah, blah, blah. So there's a lot of different ways how people help each other in a company. And that is all great and so on. But when things keep repeating themselves, and this is especially evil word, that's why it's in red, can you just do something? Then perhaps it's time to rethink this engagement. Because it's a known saying that like if you're really good at what you do, then you also get to do the work of others. And also, like, what's your process? So I do this and that, and then I ask a guy who will do this for me. So having friends in the company who do stuff for you is bad. For multiple reasons. First, you're not independent, you're not self-sufficient, but also, whenever you ask someone to help you with something, you're basically breaking their context. They have stuff to do, and you're basically giving them an ad hoc thing that they need to help you with. So, by saying that friends are enemies, how can we like kill this friendship? So, there is a saying: give a man a fish, feed him for a day, you'll know what happens next. So, instead of helping out someone, figure out a way for that person to help himself. So, teach a man to fish and you feed him for a lifetime. Now, of course, there are different things that happen when people start to fish. They need to get a fishing license, then if they want to cook the fish, they need to have a permit for an open flame, and other type of stuff. So not every freedom should be given, because taken directly from Big Brother is watching, freedom is slavery. And I'll try to explain what type of slavery. By slavery, I don't mean like literal slavery, I mean more like slaving in the kitchen. So let's say that a person gives you freedom to do something. So you just got sudo. Great. So what do I do with this sudo now? Well, now you can use sudo to inspect the application logs. Well, that doesn't sound like much of a freedom. It's more like slavery, because my premise is that sudoing in the truth is the same as slaving in the kitchen. So if you give someone freedom to do this because you don't want them to bother you, then you didn't really do much, because the vicious cycle will repeat. They will need to do more and more stuff, and you didn't really solve the first problem in the first place. So, a very stupid example, but instead of having giving sudo rights to people to look at application logs, perhaps we should do some kind of log aggregation, give them rights to audit these logs. Okay? So, as I said, there are different types of fishes, and some fishes should be, well, given the rights to. You know what, this fish actually is becoming a bit of a bore, so I'll just explain what it counts. So does anyone know Swahili? Okay, so basically in Swahili, fish stands for continuous integration. Okay, so just look it up, it's obvious. So teach them to fish, so direct translation would be build continuous integration for peeps, and they won't bother you for a while. Okay, so instead of friends or enemies, there are no enemies because there are no friends, because people are now using continuous integration. So how do we go about this? So I'll give you an example in Oradian. These are the potential frenemies of Oradian. These are the 5 tech teams that work together to build the core banking system that we do. So we have your backend team. That's the hard hat hackers that do all the nitty-gritty business logic and so. We have the front-end hipsters who are doing the React. We have R&D who's doing a lot of stuff with elephants and stuff. We have QA analysts and engineers for quality, and we have an infra team. It's not just Jenkins, an infra team does everything, but Jenkins is kind of their thing, like React is front-end thing. Okay, so these frenemies what are we going to do? So we're going to have an evolution of our process that we are going to document the situations where we need friends to help us, and then these friends are going to automate it for us instead of doing it for us or giving us the permissions to do it. So first off, documentation. Documentation is created by a friend, someone who knows what needs to be done, but the important part is that it's maintained by people who don't understand what they needed to do in the first place. Because if the documentation is continuously maintained by this friend, again, you didn't do much. You didn't pass the knowledge. So after the initial creation of the documentation, it's best that the newbies who you're introducing into this process, that they help out with furthering the documentation. Because they are not polluted by tribal knowledge, and they don't understand, oh, this is just how we do stuff, right? So they will learn, and they will give you feedback, this is horrible. Why are we doing this? We need to change this. So do not underestimate the power of people who are not polluted with tribal knowledge. So once you have documented certain processes, people will achieve a level of independence, because even in the chance that, let's say, CI disappears, goes AWOL or something, you can always reproduce this by hand. So example of how documentation could be done. I don't know how to exit this jail of my machine. Okay. So a couple of examples. Flomp. Let me just open up a few pages so you get an idea. Okay, we have complex documentation that's very like specific, like okay, this is your stuff. And then you have even entry level documentation. Okay, let's say install front-end environment, basically how we're going to do this and what are you going to do and so on. So this is documentation that is usually maintained by the last person who did this for the first time. That's what I meant by maintained by newbies. Because you already know this. So why would you document this? You're not documenting for yourself. You're documenting for the other people. And then once they want to do this, they run through the documentation and they do it for themselves. So that was the first step of documenting the process. Next up, it's having friends automated. So for reasons that we're going to clear soon, I would propose that you do an MVP. There is no excuse not to do CI. There is simply no excuse. I mean, how many times did you hear, we don't have time to write tests? It's a thing. Like everybody's talking, oh yeah, we have tests, yeah, we have CI. Like, but then you talk, oh yeah, that's cool, yeah, I wish we had something like that. But why don't you invest like the minimum effort into some kind of automation? It's the same thing how you would invest minimum effort into some kind of test. So it's an MVP. You do a breadth first approach. So you tackle with 10% effort the 90% of automation. And this is literally something I did completely disconnected to this talk yesterday. I made a Windows scheduler just for the fun of it, where I can't really see what I'm typing, but in order to try out some, I don't know where I am now. I basically wanted to show you that I wrote a bat file which runs like 50 things in order to see what's going to happen before I do a proper CI. And I let that thing run every hour on my local machine to see how it's going to behave. So literally that means you need the minimum investment to do this type of initial automation. Okay, so this is how it looks on our end. And what we did is that Infra now became a service provider for various users inside our company, for QA backend, R&D, front-end, and Infra will build the automation that we need. So we have your own generic Docker with Javas, it installs SBTs, and it's going to do the compilation and run tests. We have your Node and Yarn, that's for front-end and reacting. They're going to install stuff, do their run and their build and their test. Then Infra will establish a pipeline. It's going to say on every bit bucket push, we're going to go into this pipeline to those couple of Dockers, which took, as I said, MVP, minimum time to build. And we're going to have a pipeline which is going to basically like check out the code, do a build, run some tests, try not to fail, and notify Bitbucket that it was done. And that's it. So questions? Okay, so that's not really it, because there are problems with this approach. So the problem is what happens when you scale up. There are organizational problems with this approach. So This is a live, I'm telling you that this is what happens in Auradian, and we're currently transitioning through it. So the problem with this approach is that I said that if you build continuous integration for other people, that they won't bother you for a while, right? But what happens is that it basically introduces some sort of a chasm between your infrastructure people, who are your sysops, DevOps, and so on, ops people, and the lowly consumers of their integration systems. And they even like start to like physically bundle together, like, oh, those infra guys, yeah, I'm waiting for them to do this, yeah, this build crashed again, like, what do we do, and so on. So it literally became something like this in our case. So this is Mount Sinai, and this is like the lowly people waiting for infra to come down from the mountain and bring the new CI/CD. So it's not a good environment. These are like lightning bolts. It's an animation that I'm performing using my clicker. Okay, so how to solve this? So if you build continuous integration for pips, they will want more and more. That's good. It's good that people want to automate stuff, but who will do it? Teach a man to continuously integrate, and he will build for a lifetime. So don't give him continuous integration, teach him how to continuously integrate, and he will build for a lifetime. And especially if you're using Scala, it's truly building for a lifetime, because it takes bloody ages to build your project. But that's where we want to go. And how do we concretely do it in Auradian? So we added another step to our evolution. Remember, the first two steps, we documented the process for reasons. And then we had the first run where we automated it. And then we remember that the first information was a crutch. It needs to be crappy, trust me on this. Don't build like end of the world perfect system, because there is no such thing. Just do something, remember, 10% for 90%. And then it's time to do proper education. So this is the part where you have actual supporting friends. This is the only part where you actually need friends in this entire agenda, because now is the time to help them, because now they need to actually understand the CI tool, and you need to push it down to them. So let's go back to our teams. This is our process, which is kind of obvious, but okay. So we have a couple of teams who are building stuff. Then we have someone who is testing that. Then it's a iterative process, after which we ship it. By placing a separation of concerns between CI and CD, that means that all the teams that are part of our company can really focus on all the parts of their work, like from start to finish, including CI, while infra can focus on the other stuff. Remember about breaking context? They got stuff to do. They need to build orchestration. They need to do like single-click deployment to other data centers, scaling, and blah, 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 all the stuff that you don't really see in development. So they got their own kind of thing. They don't have time to work on your CD. So example time. Now, I'm hoping that you will be able to see the screen for a bit. I'll basically show you a redacted. Oh, come on. This is stupid. I should have thought this better. But okay. So the way it looks is like this. What we did is we have a monorepo, so to start things off, I'm ready for flames. So we have a monorepo, and inside this monorepo we have all the code. So this is a particularly gruesome code base. It's about 35 megabytes or something like that. There's a lot of stuff in there for like front ends, back ends, QA, and so on. So literally in the components, that's our front end part. In the QA, this is where I keep our QA tools and tests, and the rest of the stuff is backend, right? So what we do is we defined a build folder inside our code base, inside our monorepo, and inside this build folder, depending on the team, here is where that team keeps their CI stuff. So it's no longer hidden on some server that is going to run your stuff. It's actually inside the source code, okay? Okay. So let's take a look. For instance, if we have that backend build, then we have backend's Docker file, which says, well, the stuff we just saw previously, and you need to understand the difference. previously, this Docker file was maintained by Infra. They had their own server setup where they built Dockers, deployed new versions of Oracle, Java, whatnot. And whenever you needed to change something, hey, can you please put in, I don't know, next version of SBT? You would need to go to your friend, even though it's CI, and tell them, can you please bump this version of CI? So now this is in your source code. So that means that once we push to Bitbucket, this entire source is pushed to CI. The CI looks into these folders and determines what kind of strategies should be deployed for all the consumers of CI. So example, in my presentation, I can actually go back. Okay, I'm going to enhance. Okay, so this is example of how, of a small DSL we wrote that explains how the test should be run. So, do you remember previously that I showed you a hard-coded pipeline that said run tests, run build, then done, right? So that was configured by hand in Jenkins. Well, this is live in that source file I just shown you. So it says, for this example, that we're going to run in parallel both backend and frontend build. Once the backend build is successful, we're going to run backend tests in parallel to smoke tests, and the same thing on frontend. So it's a small DSL that we put in. Okay? So how does this help us? First, it's shamefully parallelizable. Because there is no longer a single Docker virtual machine image that we need, where we want to run all our tests and so on, every image is dependent on their branch and commit. So that means that you can also customize what you want your CI to do with every branch that you push. It also means that, so for instance, in the previous slide, I'm going to zoom in upstairs. Example. Come on, pointer. Okay, so let's say that this is our current procedure. We want to run backend build, backend test, frontend test, and smoke tests. So let's say that you intentionally broke the front-end test because you're testing some API. You don't really need front-end, right? So you literally just delete this line. You kill this line in the invocation below, and you replace this backend test with some other step. And thus you achieve full automation. Example, let's say that after I push a commit to Bitbucket, or GitHub, or whatever CI, whatever source control thing you use, let's say that I want to build an instance after every commit. An instance is basically an application live that basically deploys and you can see it live. So what you do is you literally add another def that says, run this Jenkins job for me, and once I commit this source, it's going to run a mutated version of the build that is tailor-made for that developer which is doing work on his branch. So you can understand that this is now pushing the entire CI responsibility onto whatever team is modifying this build file. I'm ready for questions because you guys look a bit worried. There's time, you can stop me. Okay, so the result is that each team is independent. There is no more orders from Mount Sinai, because now each team is in charge of their own builds. You have happy, empowered peeps that are no longer requesting friends for help, except for the education part. And there is a difference to how it was than to how it is now. So these are custom Jenkins jobs that these teams have created for themselves without Infra's assistance. It even goes a bit more gruesome in that actually we also have Infra now with their own custom jobs that they created for themselves, because previously we had a couple of Jenkins. We had a production Jenkins, a staging Jenkins, and a test Jenkins. Now literally every developer has their own Jenkins, which is fully customizable. So you can imagine the shamefully parallelizable thing applies not only to builds, but the actual testing of the CI system itself. So it's a bit of a recursion here, but that's the intent. So we want to be able to CI our CI. Okay. So now questions. Come on, people.
How much time did it take you to get some basic CI setup?
Basic CI was done, I'd say, in a couple of weeks, and it was crashing horribly for about a year. Literally for about a year. But there are a lot of ways how you can help with this. So the problem is that a lot of people who work like on CI and CD, they forget that they, as other teams as well, they need to have their own tests. And the teams that we are the consumers of the initial tests, actually I can show you this. Example, search. How do you, for instance, test this, CI/CD testing? So what we had, this is an example. These are a couple of scenarios that you want to do to intentionally crash the build in horrible ways, right? I literally put in a shiji, so it won't even begin to pass. It's going to crash horribly, right? Then you crash this, you crash the build, you crash the test, you crash the migration, you crash this. So this is just one page. There are actually scripts that you run, that you can do a nightly run and run 20 different scenarios that all need to crash with a nice descriptive message. This is what we learned on our example, because we were literally for 1 year, we were gathering all kinds of errors that we got from production. So you need to understand, remember the fishes of different color? So the code part is on the teams, but when something happens like inodes exhausted on file system, something like that's really infra territory. They really need to do that part of it. So it was a process, but you can help that process by pushing for testing of the CI/CD system.
What's in the process? Because you want it to be really awesome, or really the entry bar is so high to get in CI? Like
It's completely.
quick, cheap way of getting CI.
There's a lot of there is a lot of out-of-the-box solutions. We have a fairly complicated build. The thing you're seeing is a reduced subset. So you can literally hook into Travis CI. Look at my GitHubs. Literally everywhere I have a Travis file, it's 5 lines of code. It will build stuff for you directly. If you have a system that is well behind firewall, as we do, because we're developing a financial applications, blah, 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 it's highly proprietary, so we need to do everything in our Jenkins, and we don't push to external CIs. I think the entry bar is as high as the other comparison that I said as writing tests. So I don't want to point out and do the hands raising, but I'm sure that in this room right now there is a lot of people who still in their team don't write tests because they don't have time. It's the same thing. If you want to do an MVP, you can do this in a matter of days, maximum weeks. It's going to take time to iterate through it, but you'll be able to pull it off. The branch itself is the Docker file. That's the gist. There is no disconnect between the source and the Docker. The Docker is in the source, so it implicitly matches the code.
Yes. If I, for example, modify and delete the front-end tests for my feature branch, everything is okay. And what happens if someone merges that branch?
Currently, because we're evolving this, only 5 minutes. What are you talking about? 23 minutes. Okay. So currently, we don't have anything other than code review. You need to review the changes in the Docker file as well. Before you push to RC, before you push to master, you should revert back to the stable state of the original setup, right? The easiest way to do it is to have a post hook which rejects any changes on the build file if it's not approved by infra. That's also a way how to avoid some security implications. Currently, we don't have much because the systems that are building stuff are slaves that are completely disconnected from all of our environments, even testing environments. So it's okay if they say something in there like rumor of a root. I don't care. All right, so the slave is just going to delete itself. We're going to provision a new one. And the testing of the build is that same thing. You saw me crash the build. You can also have tests for crashing the Docker, because the first step is to build a Docker image, then the test to run the thing inside the Docker, and then, it's every step of the pipeline. So the first step of the pipeline will be read, and it will crash. You will see it in the results. And you need to write a test for that. Shiji. It's awesome. What's up?
How many environments, virtual machines, or anything you have for the CI CD? Because
Mm.
has to deploy somewhere. So do you create a slave machine for that and then do it later? You
We have
100 virtual machines running?
yes. So we have two separations. So we have CI/CD. So the CI part is done on slave machines, which are basically your bare metals, your Hetzner's, your whatever. Just get a gruesome amount of CPU. You don't need RAM, you don't need disk. Just lots of RAM for like $60 a month. You can get like really crazy amount of CPU on Hetzner. Okay. So that's the first part. So we have currently, I think, 10 of these machines. We have Ryzen's and i7s, and it turns out that the Ryzen's with their super high threaded, like 48 cores, they're actually slower than the i7s because it's all about the tact for building Scala. So that's why we prefer the i7s. Now, after the CI is done and the jar has been created and the assets have been compiled, we then deploy to our staging environment, which is the copy of our test, pilot, and production environments. And then it's completely isolated, and currently it has 300-400 instances running in it. I don't know. So basically, we have a staging environment to which we then do CD. Right? This is mostly about CI, but CD is then how to provision this environment and how to run the actual app. That's really infra part. But the CI was more meant for this discussion, right? Go. Yes. Unfortunately, it's not open source yet, but if you join a Radeon, you can see it for yourself. So, yes, it's not open source yet, but for this particular, it was a really big project. It took months, and to test it is, it's completely flexible. When you create a Jenkins job that just says build, test, and report, that's much simpler than we need to create Docker with every. So it was I think 4 or 5 months in testing. And it's not yet replacing all of our builds because production builds are still using legacy build. This is for development. So it's a lot of effort, but now it's completely pushed down to the teams, and every team is complete control of their CI.
One more thing, because we are planning on doing CI, and we are planning on having Amazon requirements of demand for every batch coming from it. What's your recommendation to start doing something like that in-house, or just to do it simple? Deploy everything, run Selenium tests after test pass, and that's it. I mean, is that...
Well, I have a personal beef with Amazon because that's okay if you have like scale on demand, you need 100,000 CPU powers to do something. Try these bare metal services, they're cheaper because builds are seriously CPU intensive. As for the Seleniums, there are different options. If you have the ability to use Vsauce Labs, what's the name? They have a lot of different better Seleniums that the thing you're gonna cook up. It took us also bloody ages to get Selenium working, so you didn't see any of this stuff. But literally imagine like emulated Androids inside Dockers, like doing requests to a staging instance we just deployed for a system test. It's a lot of work. So it's not as simple as it looks, and it was really tiring. Also, it was really tiring for us, especially because whenever we did any change in the configuration of the Selenium or any of the components, and these things are brittle as, I don't know, as glass, we always need to, hey, infra, can you please help us? So the point of this talk is that it's not enough to just have infra automate stuff because the demand actually grew larger. Like they were constantly bombarded, like, hey, help me with this. This is not working for us. So it is a bit of an effort. If you're going to drink the Kool-Aid and like go all into Amazon, I'm pretty sure you can get everything done inside their stack, which is humongous. But we decided to go, well, with building our own. By no means this means that Jenkins is awesome. There are thousands of others, no, tens of other CIs. So this is just the idea of this talk is to push the responsibility onto the teams, not the actual technical implementation. You need to understand that as you scale up, you cannot, 30 minutes? That you cannot simply make it work unless you push the responsibility. And that's 30 minutes. Okay. And actually, since we invested so much work into this, and it's really not a company secret, perhaps we can now open source this build, because it's truly a really great piece of engineering. And we are sure to demo it on the DevOps meetup that's now being hosted in Zagreb. So we're going to first show it there as well, and perhaps open source it. So. Oradian's GitHub.